Now we come to another very important feature. It's the so-called turbidity regions in positive estuaries. In positive estuaries, we have the problem that sediments accumulate in a particular region, and there's more and more sediment turning up in that region, and often this turbidity region has to be dredged away. Okay, in particular if it's near a port. Okay, why do you get a turbidity region? Positive estuaries are traps for sediment, not for all sediments, but for many, for a broad range of sediment sizes. Okay, let's have a look at that example. So what's shown here is the general circulation of a positive estuary. There is an outflow in the top layer towards the ocean, into the ocean, and there's an inflow of seawater underneath. So you have particles within this flow. Very, very fine particles stay in the upper layer and just become flushed out into the ocean. A little bit larger particles, coarser material, over the length of the estuary, they sink into the bottom layer, and in the bottom layer there is an average movement into your estuary. Okay, so this is a trap for sediments. The sediments become trapped in the lower layer, and sediments become moved up the estuary and end up in a turbidity region. All right, so that is, and this turbidity region is located in a salinity range which typically between 5 and 10 salinity units. If you know the salinity distribution, you can, from the salinity distribution alone, you can tell where this sediment is. Okay, it's very, very important. Okay, this turbidity region does not exist in negative estuaries, in inverse estuaries, because the circulation is different. Okay, because you have an outflow in the lower layer. So essentially, inverse estuaries rather flush out the sediment. Here you have a trap. And I want to show you examples on the next slide.